Hello and welcome to this video where we will take a general overview of artificial intelligence. I have created this video for IT professionals who want a clear, simple introduction to AI because AI often seems like a mysterious and futuristic concept, especially if you're not a developer or coder. This video is divided into two parts. Part 1, in this we will focus on general overview of AI, and part 2 will focus on AI cybersecurity, its risks and concerns. To simplify AI, we will compare it with human intelligence because both share many similarities in how they develop. Both AI and humans are built on two fundamental components: a model and datasets. A model, so humans have a biological model pre-built by nature, which consists of brain, nervous system, memory, decision-making process. Similarly, AI would also have a model which is designed and built by developers and coders. And then we have data sets. As humans, we collect data sets from the environment using our senses, experiences, and exposures. Similarly, AI trains on data sets of images, text, numbers, and patterns. Before we understand artificial intelligence model, let's first look at human intelligence model and how our biological model works. At the core of our biological model is survival. Nature has designed this survival mechanism in us, meaning that even before we develop logical thinking, we have these instincts built in us to react to protect ourselves. For example, a newborn baby does not understand what fire is, but if exposed to heat, they instinctively withdraw their hand. This is because nature has programmed these reflexes into our biological model for survival. And there are many more components such as molecular and chemical reactions, genetics and DNA, skeletal and nervous system that go into building our biological model. However, these components do not exist in an AI model. So we will skip them in our discussion. Instead, we will only focus on the components that are common or similar between human intelligence and artificial intelligence, the ones that form the foundation of both. These includes mathematics, decision gates, memory, correction mechanism, improvement process. So these are some general components which are similar, common between human intelligence model and biological model. By focusing on these components, we can clearly see the parallels between human intelligence and AI models, and we will be better able to understand the AI model. Now that we have established which components we will focus on, let's explore them one by one. Decision gates, activation functions. Every second in humans, our brain makes numerous binary decisions, whether we should stand, we should sit, whether we should move left, we should move right while walking. This is similar to activation functions in AI, which determine whether a neuron in an artificial neural network should fire or remain inactive. Just like our neurons in our brains process real-world stimuli, AI model uses activation functions to process and pass information forward. Then we have memory, weights and biases. Our brain stores and recalls information on a priority system. For example, if you meet a friend, a childhood friend after 20 years, you will still recognize them, right? Even if their appearance has changed dramatically. This happens because our brain assigns a weight to unique features of that person, like their voice, gestures, or way of speaking. Similarly, AI uses weights and biases to prioritize important data and improve its recognition and decision-making abilities. And in our memory, we also use biases, right, to improve our decision making, to make our decision making fast. But biases also have a downside. Let's discuss them because that is what makes this interesting. Imagine you meet someone who wears glasses and speaks softly, and from your past experiences, you associate glasses with intelligence. Then you will start assuming that everybody who wears glasses is highly knowledgeable and intelligent, even if they are very dumb, because you have developed a bias. So this is a cognitive bias. The cognitive bias is a shortcut that our brain takes to quickly judge people or situation based on past experiences. Similarly, in AI, we also see biases. Let's say an AI resume screening system is trained on past hiring data, where most selected candidates were male engineers. Then the AI will assign higher weight to male hiring in its decision process. It might start unfairly rejecting equally skilled female applicants. This is because of the data-driven bias that the AI has developed. Unintentionally, it inherits this historical biases from the training data that male engineers were hired more, so male engineers are good for this profile. Then we have correction mechanism. Just like humans learn from mistakes, similarly AI also have a loss function that calculates how much error is present, and based on that it adjusts over time. Then we have improvement processes. As humans, we refine our skills by repeating the experiences, right? For example, if we have learned swimming, then we will repeat swimming. With practice, we will improve over the time. Similarly, AI models also have these optimization algorithms that constantly improve their performance and accuracy. Then one of the most important components is mathematics. That is the reason AI is described as mathematics at scale. And with advanced AI, more and more demand for advanced mathematicians is increasing, because AI makes use of a lot of linear algebra, calculus. We will see how. First, let's understand in our human body, in our biological model, how maths is working and how it's an important component. So imagine you are drinking a cup of tea. Before you move your hand to hold the cup, your brain estimates the distance between your hand and the cup using an equation like this. So your brain, it might not be actually solving this Pythagorean theorem equation to calculate the distance, but instinctively it is using something like this to calculate the spatial distance between your hand and the cup, and that is how it is estimating and allowing you to reach for the cup accurately. Then there is a lot of statistics in our body as well. I mean, our brain constantly considers past experiences to estimate the likelihood of the cup slipping from our hand. For example, if you previously picked up a wet cup and found it slippery, your brain automatically adjusts your grip strength to prevent the cup from slipping this time if it is wet. And AI systems work in the similar fashion by using probability models to predict outcomes and making decisions. Then there is force equals to mass into acceleration, Newton's equation. As you lift the cup, your brain determines how much amount of force it should put based on the cup's weight. If the cup is full, you will apply instinctively more force. If it's empty, you will apply force less. All this is unconscious process, involuntary process that is happening within your body. This is like Newton's second law in action, force equals to mass into acceleration. And when it comes to AI robotics, in robotics, AI uses the same principle to calculate the required force for picking up and moving objects. In the same way, these rate of change, friction equation, all these equations are running in our brain. We cannot say that exactly human maths is running in our brain, but something equivalent like this is running in human instinct, and that is how we function, right? And that is the reason I'm saying that maths is in everything that we do. And in AI as well, math becomes a very important component. The better the math, the more efficient, the more accurate the AI would be. Now that we have understood the biological model and its components, let's move on to another key factor responsible for shaping human intelligence, that is datasets. Humans rely on datasets to develop their intelligence, and humans get their datasets from nature and environment. The world around us constantly provides us information that we absorb from birth. Then we also get datasets from our parents in our early childhood that are very crucial in shaping our understanding. We get formal education from schools and institutions. As we grow, we make friends, we become a part of community, we open social interactions, so we learn from people, conversations, shared experiences. All of these data sets we are consuming using our senses, our eyes, ears, touch, smell, and even our intuitions. These data sets then help refine our intelligence and decision-making ability. And similarly, if we have to draw parallels with AI, then AI also relies heavily on data to build its intelligence. Instead of learning from nature or parents, AI consumes images, texts, numbers, structured data that is given to it by its parents, that is developers. And that is how AI improves its intelligence and decision-making capability. Now, one key observation is that no matter which AI model you're looking at, whether you're looking at large language models or vision models, this structure will remain common. These two fundamentals you will find in every model. They will always require these general components, and they will require data sets. So the expertise of the AI model will depend on the type of the data sets that you are giving to the AI. The type of data that AI is trained on will make it an expert in that field. AI trained on financial data becomes an expert in stock market predictions. AI trained on human language data becomes an expert in chatbots like ChatGPT. Just like humans, right? When we go into college, we transition from consuming general datasets to specialized datasets based on the domain we choose to pursue. For example, medical students, they will focus on biology, anatomy, and healthcare. Tech and engineering students, they would feed on datasets related to physics, AI, and programming. Finance students would consume datasets related to economics, markets, and risk management. This selective learning allows us to become experts in a specific domain. Now that we have looked at human intelligence and its subfields, it is time to look at artificial intelligence and its categories and subfields. So artificial intelligence is a broad category under which you will find categories, subfields such as machine learning. In machine learning, AI software that learns from data and improves over time will fall under this category. Applications such as Netflix, Amazon, they recommend videos, products to its users based on past behavior. Under machine learning, you will have another subcategory that is deep learning, an AI that uses neural networks to process complex data and recognize patterns. Example of this would be Tesla's self-driving cars. You have reinforcement learning. Under this, those AI softwares that learn by trial and error and improve by receiving rewards for good actions, they fall under this category. Example is this AlphaGo software. Gen AI, which is a very famous category under AI, ChatGPT, a very well-renowned software. So any software that is capable of generating text, images, music, and videos, it will fall under this category. Generative itself suggests to generate, and any AI software that can generate unique text, images, music, videos, content, that falls under this category. Then you have natural language processing category, under which you have AI softwares such as Alexa, Siri. Now I would like to specifically talk about the reinforcement learning category, and in this, the AlphaGo moment, how reinforcement learning changed the AI forever. So one of the most groundbreaking moments in AI history, if you have to look back, it happened in March 2016 during a match between AlphaGo and Lee Sedol. So AlphaGo is a software that was developed by the company called DeepMind, and Lee Sedol, he's a South Korean player who is an 18-time world champion in the game Go. Go is an ancient Chinese board game that is considered 10 times more complex than chess. It requires deep strategy and human intuition. What made this match historic was move 37 made by AlphaGo, which was a completely unexpected move that no human player would have considered. This move 37 during this match, it shocked the world, because at first commentators thought that AlphaGo had made a mistake, but soon they realized that the move was actually brilliant and creative. And why was this move special? Because AlphaGo didn't learn this move from human players. It didn't learn this from going through different matches that were fed as data sets to this AlphaGo. It discovered this on its own by playing millions of matches against itself through reinforcement learning. And it demonstrated that AI could go beyond human intuition and create new strategies that even best human players have never imagined. So this was a historic moment because it showed that AI wasn't just imitating human players anymore. It was learning, innovating, and even creating new possibilities. So that is the reason, AI changed after this forever. And there is a beautiful documentary on this with the name AlphaGo available on YouTube for free to watch. If you want to further understand these AI categories in simple manner, then you can compare them with human intelligence subfields, understand what scope they have and what all machine learning covers, what all deep learning covers, and understand them in this way. Now, one more thing I want to talk before I end the video is parameter size. The parameter size in AI is very important because AI models rely on parameters to determine their intelligence, accuracy, and complexity. The higher the parameter count, the better AI can recognize patterns and generate responses. For example, if you see here GPT-2, GPT-3, their parameter size was very less when you compare it with ChatGPT-4, which is estimated to have 1 trillion parameters, making it highly advanced and multimodal, capable of handling text, images, and even videos. Down here, for fun, I have shown you human brain that does not work in terms of parameters, but in neuroscience, you use a similar term called as synapses. So we have more than 100 trillion synapses in our brain that we use for creativity, general intelligence, decision making, reasoning, etc. If you have to understand parameters in a simple way, then think of them as parameters like knobs on a sound mixer. The more knobs you have on a sound mixer, the more capable the sound mixer is of producing variations and fine-tuning and producing new music. So in the same way, you can understand that the more parameters the AI has, the more capable and sophisticated it would be. Okay, so that's it in this video. What's next? In part 2, we will discuss about AI cybersecurity. For that, we will install an AI model on our system. I will not do a live installation, but I will show you screenshots of the installation that I've done for an AI model on my system and how using an API I access that AI model and what are the cybersecurity risks in AI and how to secure AI systems. Thanks for watching then. I will leave you with this thought. AI is not magic, it's just mathematics at scale. I'll see you in the next video. Thank you for your time.